Alrighty, let's take a look at these. We talked about these yesterday, that there's 3 synonyms for our solutions. What's one of those? What's one of the other words we can use instead of solutions? Zeros. X-intercepts. One other one. Roots. So zeros, x-intercepts, roots, solutions, those all mean the same thing. So then on this picture here, we're asked to find the solutions, the zeros, the roots, the x-intercepts. So on this picture, where are the solutions? Numbers. Yep, -4, 0, that's one of them. And 2, 0, this guy over here. Where it crosses that x-axis, those x-intercepts, the roots, the zeros, that's where we're finding our solutions. Then these right to, it's very changing vibes here. This is some old school stuff. What is the square root of 16? 4. Because 4 squared gives us 16. What's the square root of 50? What we're doing here is we're breaking these up into perfect squares. We know that 16 is a perfect square itself. 50 doesn't square root super nicely all by itself. It's going to be decimally. But usually when we were working with square roots and trying to simplify them, we'd break them into multiples. So 50 is the same thing as 25 times 2, right? That's absolutely the same thing. By splitting it up like that, I can make this be the square root of 25 times the square root of 2. The reason I picked that is because we know the square root of 25. What is the square root of 25? 5. Do we know the square root of 2? No, it's decimally and gross. And there's not another perfect square that's a factor of it. So 5 square root of 2. The yellow calculators can simplify radicals like that, but what we're going to be using square roots for like today and tomorrow, we're not going to be able to type them in the calculator because it's going to give us an error. And we're going to talk about why. But so we need to be able to do these ourselves, like kind of by hand. Old school. Because the calculators, don't know how. Questions on these 4? Cool. So we're going to go in your notes packet to page 7. And we are going to deal with a problem that mathematicians faced and couldn't come up with a real solution, so they made one up. Quite literally. It is called imaginary. It's I. This is one of the reasons we've never used I as like a variable on things, because it has a thing in math, it means a thing. Because the problems we run into with square roots, and this is something you can do if you type it in the calculator, we did the square root of 16, but what if we tried to do the square root of -16? We can't do it. We'll get a domain error on a calculator. Because what mathematicians ran into, and they were really, really frustrated at not being able to find a solution, is they'd get stuck whenever we had a square root of a negative number. So what they did was to be able to find a way to get it all the way down to an actual answer. They said, okay, fine. We will take the square root of a negative number and we'll make it be a thing so that we can finish out the problem. Because it just bothered them that much. So we have this letter I. It's just an I. The font for math makes it look all fancy and scripty. It's just an I. It's the square root of -1. So it's a very, very specific number. And it's a very specific thing that cannot happen. Because the one thing we're not supposed to do with our square roots is we're not supposed to do the square root of a negative number. So I is actually the square root of -1. That's the one thing that cannot exist. It doesn't work. So if I was to, say, square both sides of this to look at what I squared would be, that would be if we had our square root of -1 and then squared it. What happens when I square something that has a root like that? What happens between the little root and the 2? They undo each other. They cancel each other out. It's like multiplying by 2 and dividing by 2, or adding 2 and subtracting 2. Squaring and square rooting undo each other. So I squared is the only thing in existence that, when squared, is negative. I squared equals -1. I'm going to switch that up so it's way closer to my line. So we're going to be working with squares, we're going to be working with negative numbers, and we're going to be looking for perfect squares. So I want us to try and remember as many perfect squares as we can. What do we know are numbers that are perfect squares? Say it louder. 20 is not a perfect square. Not 20. So what is 1 squared? 1. So 1 is a perfect square. What is 2 squared? 4. So that means 4 is a perfect square. So these numbers that we're getting when we square something are our perfect squares. So what would be our next perfect square? 9, because that's 3 squared. What's our next one? We jumped one. 4 squared gives us 16. And then we could do 5 squared to get our 25. We could do 6 squared to get 36. 7 squared, 49. 8 squared, 64. 9 squared. No, not quite. 81. 10 squared. 100. That's honestly most of the way we're going to go. I'm going to go all the way up to 12 just so that we have it, because we're used to doing usually up to 12s. But we are very rarely going to ask you to know anything above 100 on site. 121 would be what 11 squared is. And 12 squared is 144. Now, I could keep going. I could do 13 squared. I could do 14 squared. I could do 15 squared. I could do 20 squared. I could do 100 squared. There's so many perfect squares. These are just kind of the smallest ones, so they're the closest ones we're going to work with. So when we're looking at simplifying radicals like the ones we did in the bell work, these are the numbers we're trying to find that are factors of it. So when we were looking at that 50, the largest perfect square that I could divide out of 50 was 25. So that's why we took the 25 out there. So these are kind of going to be our home base when we're looking at simplifying radicals. These are the guys that we know how to work with. So what we're going to do for this first set of them, we're going to combine the fact that we now know that the square root of -1 is called I, and we have a whole bunch of perfect squares here. And we are going to start by trying to do some simplifying. So, just below this, number 1 asks us to do the square root of -25. Well, we know what 25 is. We've already looked at that one. It's the negative that gives us the problems. So what we're going to do when we're simplifying these radicals is we're going to break them apart into pieces. I'm going to make this -25 rewritten as -1 times 25. Oh, I'm writing very small. There we go. When I do that and I split that apart into being a product, I can actually split that apart even further to make this be the square root of -1 times the square root of 25. I can break them apart into other things. They will remain being multiplied. This does not work if it's being added or subtracted. It's only for multiplication. And then we know some of these pieces. I know the square root of 25. The square root of 25 is 5. And we just said on the previous page that square root of -1, that was the mathematical problem child that mathematicians invented something to fix. That square root of -1 we call I. I always throw a little hook on my I just so it doesn't look like a 1, but it genuinely doesn't matter. So we wind up with I times 5, which is kind of like x times 2, which is not wrong. It's just kind of like Yoda speak. So our final answer here is going to be 5I. Thank you. So this is that important new piece, that our square root of -1 is what we call I. Typically when we're writing out these imaginary numbers, which is what this is called, we want to have the number and then the letter. If we have anything left in the radical, it's going to be number, letter, radical, in that order. I'll show you what I mean here in a second. So let's look at number 2. Oh, yes, dear. We're gonna simplify it as much as we can, like we did the 50, like this guy. So it'll just be like our number, and then if we have an I, it'll go in between. Boop. So on this next one, on number 2, we have the square root of -2, and we're gonna do this very, very similarly. I'm gonna take this and I'm gonna split it apart so I can rewrite this -2 as -1 times 2. So I break it apart into multiplication. Then I'm going to split these apart into separate pieces. I've got my square root of -1 times my square root of 2. Well, the square root of -1, that's the piece we call I. That is our new piece for today. Anytime we have the square root of -1, that is I. 100%. Can we simplify the square root of 2? Are there any perfect squares that I could divide 2 by? I mean, technically 1, but that doesn't help us at all. So this is just going to stay the square root of 2. It doesn't simplify at all. So that's actually our answer. I'm just going to rewrite it. I square root of 2. We don't want to put any letters, including I's, after the radical, unless they're supposed to be inside. I's should not be inside the house. Period. So we're not going to write them after we draw the house. And then number 3 is going to kind of combine these all together into one piece. Questions on 2 as it stands right now? I know this is weird. One of those things. So on this one for number 3, we're going to again split this apart. And we can do this as -1 times 12. Totally valid. Or we can go, hey, wait a second, I need to simplify this 12 anyway. Is there a perfect square that I can divide 12 by? Was 3 a perfect square? But it does have a factor that is. Other way around. I want to be able to divide 12 by one of these numbers. 12 divided by. Which one's not going to give me a decimal? Can't divide 12 by 16? That's not going to work. I can't take 12 divided by 9? That's not going to work. But I can divide by 4. So I could rewrite my square root of 12 as the square root of 4 times 3. This all still means 12. Negative 1 times 4 times 3 is exactly negative 12. I haven't changed my expression. I've just changed how it's shaped. I moved it around like Play-Doh. If you want to do that in a couple of steps, that's absolutely valid. Splitting it up into our negative 1 and 12, and then splitting our 12 down into 4 and 3. Absolutely valid. But we want to kind of, in general, split everybody up into their own piece so that we can work with everybody individually. So we're going to have our square root of negative 1, our square root of 4, and our square root of 3. Well, our square root of negative 1, that's our new piece for today. That's our I. The square root of 4 is what? What's the square root of 4? 2. And what about square root of 3? Can we simplify that? Nah. So all of our pieces are I times 2 times the square root of 3. That's all of our simplified pieces here. Our final answer in kind of the best way, grammar on how to write it is we're going to put our 2I square root of 3. If you put I times 2 times square root of 3, like if you have all these pieces, I'm not going to be petty about it. Just don't put your I on this end. And don't have the 2 inside the house because we do have to simplify. Questions on that one? Because these are weird and kind of awkward. I'm like a thing. Triumphant. All right, let's look at the next one. We've got negative 90. Try to do our square root of negative 90. So here we're going to break this up again. I'm going to have my negative 1 times, how can I break up 90? It has lots of factors, but we're looking for one of them that is a perfect square. What can I divide 90 by that was in that list we had? 9 and 10. Because 9 times 10 gives us 90. We like that because 9 is a perfect square. 10 I can't divide by any other values that are perfect squares. So 9 is definitely the biggest perfect square I can take out of there. So then I can split these up into my separate pieces. My square root of negative 1 and my square root of 9 and my square root of 10. Well, our square root of negative 1, that's our I. The imaginary number, the made-up thing to fix the frustration of not being able to finish the problem. Square root of 9 is what? 3. And can we simplify square root of 10? No. We would need 10 to be divisible by another perfect square to be able to simplify it any further. 10 doesn't divide by 4, 10 doesn't divide by 9. Those are the only two perfect squares that are smaller than 10 and would do anything because 1 doesn't do anything anyway. So those are all of our pieces. The best math grammar will have us put it as our 3I root 10. I would 100% take either one of these. I3 root 10 or 3I root 10. I3 root 10 is just kind of like saying in your speak. Try you must. Okay. Questions on that? Because then we're going to look at the second row. where we have these negative square roots, and then we're asked to multiply them. So we're going to do this, then multiply them, and then simplify again if we need to. What's up?
How could we solve this one like we did this one?
What do you mean?
Because this one is one and 1 times me.
And that's what we did here. We did our -1 times our 4 times our 3. -1 times 12. It's the same thing. I just split the 12 up.
I mean, why do we break it up here and not here?
Because 25 is a perfect square.
Okay.
Yeah. So on these ones, we're going to try and simplify them first. Then we're going to multiply them. We want to put these as imaginary numbers first. So when we have these negative values in our radicals, we have our square root of our -1 times 2. And I have this side that is my square root of -1 times 3. So I'm again going to break everybody apart. My square root of -1 and my square root of 2 and my square root of -1 and my square root of 3. All those pieces are still there. The reason we need to do this is because I have here an I, and I have here an I. So I have two I's being multiplied together. Can we simplify the square root of 2? Can we simplify the square root of 3? No. So both of those are going to wind up staying inside the radicals. They kind of just are. So what we wind up with when we start simplifying this is we wind up with I times the square root of 2 times the square root of 3. That's what we've gotten when we started to simplify this. Well, I times I is I squared. And the square root of 2 times the square root of 3 is actually the square root of 6. Because just like when we have separate radicals here that came from it being one radical, I can mush them back together. But we have one last thing to do because I squared we actually talked about. Because if we remember, our I equals the square root of -1. So I squared is the square root of -1 squared. And the radical and the square cancel out. So I squared just equals -1. So this piece right here equals -1. So this is negative square root of 6. So we have to simplify first to get the i's out before we try and multiply things together. If we had gone straight to doing this kind of piece here with our radicals, we would have wound up with a positive answer instead of a negative. So it is important that we get the i's out before we try and simplify.
We can't just keep I squared.
Nope.
Sentence.
We gotta simplify it. In fact, I can always be simplified down so it doesn't have any powers on it ever. So that's a lot in number 5. Questions on number 5? There's a lot of steps. Okay. What's up? I said, what's up? Cool. So we're going to do the same thing on this one. Number 6 here. And I know there's not tons of space in the notes packet. I don't like how it was designed, but that's okay. I'm going to take my 20 and split that up to be -1 times, yes, dears.
You have a question.
What's that?
It's I cubed, but it just cancels out to be a number.
Working ahead. Yes, it will. Because that's I squared times I. Marquise, would you have a question too? Did you have a question too?
Oh, no.
Okay.
You said a question.
All good. So I could take my negative 20 and split it up to be negative 1 times 20. Or I can see if 20 has any perfect squares that are factors. Does 20 have any factors that are perfect squares? Five and 4. Because 4 is a perfect square. And then we also have on this right-hand side our negative 1 times 5. So breaking things apart here, just like we've been doing, our square root of negative 1 and our square root of 4 and our square root of 5 and our square root of negative 1 and our square root of 5. So both of these square root of negative 1s, we know these guys are going to be i's. What about our square root of 4? What's that going to be? 2. And then I've got square root of 5 here. And square root of 5 here. So individually, I can't simplify them. So I'm going to leave them right there just like that for now. Because what we have as we start to kind of put pieces together is I have 2i times I, which gives me I squared. And then we have our square root of 5 times 5. Bruh. 5 times 5, also known as 25. Now can I simplify this the rest of the way? What is square root of 25? 5. Oh, so now we have 2 times I squared times 5. So what's our final answer on this one going to be? Negative 10, because I squared is the same thing as negative 1. Negative 1 times 2 times 5 gives me negative 10. Here. This was our answer here. Yes, sir.
When you split these up,
Mhm.
this has to be a perfect square, right?
It needs to be one of these numbers from up here. Yep.
Yeah, but 5 is not a perfect square, though.
4 is.
So it doesn't matter?
One of them needs to be a perfect square. It's not going to be both. Yeah, that was a good question. When we're splitting these up, we just need one of these numbers to be a perfect square. If there's no perfect squares that'll divide in nicely, then it doesn't simplify. If I can find a perfect square that goes in, the leftover bit might wind up staying in a radical. Questions on these three? Well, it's a lot on one page. Okay. We've got 2 more. Bruh. And then we'll look at the...
Can we skip number 8, please?
No, it's fine. We can do 5. I'm ready. It's on. Patience. Yeah, you're right. We'll have the eye there. All right. So let's look at number 7. Splitting it apart. Yes, dear.
I did this different though.
Yep.
Yep.
Well, you could just do that the whole time?
Like,
Let me see what you got. It looked like you were doing birthday cake. So there's lots of ways to do square roots.
I I did like that.
As long as we don't lose track of those i's, because that's super duper important. Yeah. That's fine. As long as we don't lose track of those signs, totally fine. We just got to pay attention to those i's. That's just like 3 shortcuts all smushed into one. But as long as we're careful. I go the long way because it's like proper. I can split this out to be our -1 times 6 and our -1 times 18. But 18 can be divided by a perfect square. 9. 9 times 2. So we can have our square root of -1 and our square root of 6 and our square root of -1 and our square root of 9 and our square root of 2. There's lots of pieces here. We're breaking these apart into separate pieces. It's really important that we catch that we have 2 square roots of -1. That is the wonkiest shape I've ever drawn. There we go. So we've got one I here and another I over here. Our square root of 6 doesn't really simplify, but we know that the square root of 9 does. That one's going to be 3. And we still have our square root of 2. So when we combine these together, we'll have our 3i times I gives us our I squared. And we get the square root of 6 times 2. Also known as the square root of 12. But we actually can simplify this further. Because 12 divides by a perfect square. 12 can divide by 4. So I can simplify this again. And there's going to be times when we have to do a couple of rounds of simplifying. We do know that our I squared is going to switch out for a -1, so we can switch that out whenever we're ready. And our square root of 12 is the same thing as if we had the square root of 4 times the square root of 3. I'm going to get more space. So we can rewrite this as our 3 times -1 times 2 times that square root of 3. And our final answer on this one's going to be our -6 square root of 3. And there's lots and lots and lots and lots and lots and lots and lots of pathways through this. If you are comfortable with other methods of simplifying radicals, totally works. Just be really careful about that I. Some places will use the birthday cake method. Some people will use other kinds. The reason I go this way is this is something that works pretty well if we have forgotten a majority of our radicals. One more like this, and then we'll do probably 2 at the bottom, just because they're easier than they look. Huh? We're going to do this one and then 2 at the bottom. A hair tie? No, I've got like rubber bands. Like these ones, but I don't have any like spare hair ties. Yeah. Okay. So on this one, we're just going to do the same kind of thing. We're going to split them all up. We're going to find pieces we can combine together. And we're going to go from there. I'm going to split this up to be my -1 times 7. This one's going to be -1 times 21. And this one's going to be our -1 times 3. And I'm not seeing a whole lot of simplifying that can happen here, except for the fact that we have all these -1s that we can take out. So I have an I here, and an I here, and an I here. all those leftover numbers are going to go inside the radical because they don't have any buddies right now. 7 times 21 times 3. And we have our I times I times I. Well, I already know that I times I, that's an I squared. That's the same thing as if I have a negative 1. So I can simplify that down to be a negative 1. And then I have a whole nother I just kind of sitting over here. What do we notice on this? 7 times 21 times 3. Yeah, I was going to say, I see 7 times 3 is 21. So this is the same thing as if I had 21 times 21. Also known as 21 squared. So what is the square root of 21 squared? 21. So even if we don't know the exact number, it would be 441, which is a big one. But that is another one that's a perfect square. So our final answer on this one is going to be our negative 21i. And you know what? We'll just stop it there. I'm not going to try and speed run us in a problem in 3 minutes, 2 minutes, until after it's year. Mm-hmm. As long as the methods work, they work. Yeah. Yeah. There's lots of different ways through it. I just tend to stick with this one because it's the one that works. Like even if you're using a different method, you can usually find your information in here. Like all the things are in there. So I know I gave you one yesterday, but I'm going to give you another one. This one has none graphing. Okay? None graphing. This is not going to be due, I want to say, not even until at least Friday, maybe Monday. So I'm going to pass them out. But like literally we've only done the first 4 questions. So we could do, you guys could do the first 4 questions on here, and everything else we're going to talk about another day.
We just had
That's the opposite. It was not a lot.
Yes.
I do.
The 2i's combined to become a minus 1. Because I itself is the square root of minus 1. Because I times I squared. That's the square root of the square root and allowed. And you get negative 1. I is the only thing that 1 squared gives us a negative number.
We doing credit chemistry. 95. I got a test. You hate me right now, ain't you?
Alright, so I'm going to put it up here.
What you hate?
Okay, I currently have it listed as due Friday. We'll see. We'll see how we get through tomorrow.
Hey, you got some new work. Not to biology. I passed with a 90. Yep. It's okay. It's okay. It's all good, bro.
And the roots, zeros, x-intercepts.
That's all better than biology.
Hey, if the question gets asked in here, I'm likely to toss out an answer.